Hi, we are again meeting with a new and interesting topic. Already we have started this when we are in the classroom, and now we are going to start that chapter again. It will be quite interesting and also very important. So already you might have learned about the basics regarding this electricity chapter in your earlier classes, as well as from some of the worksheets what I gave to you. Okay, anyways, we'll start with this chapter now. Before going into this chapter, let us understand what is this actual name of this topic. And in the classroom, you will be playing with a plastic scale, rubbing on the hair and bringing it near the piece of papers. And you will be finding that the piece of papers will be coming and just sticking to this plastic scale. Not only that, when you just comb your hair with the dry hair, with the comb, the plastic comb, there you might be observing the one comb is getting sticked with this hair. So there you might have understood the reason behind that. So when this plastic scale is rubbed, then only it is able to attract the piece of papers. Otherwise it can't attract. And similarly, when you are just using the comb, this is a comb, okay? Comb. And when it's rubbed on this dry hair, then also it attracts piece of papers. Then why it is able to attract the piece of papers mean that you might have understood that by rubbing the body's acquired charges. Acquired charges by the process of rubbing, and we call this process as electrification. And you know the very good examples, the glass rod rubbed with silk. The glass gets positively charged and the silk gets negatively charged. And when your ebonite rod rubbed with the cat skin, this ebonite rod gets negative charge and the cat skin gets the positive charge. These examples we have to keep in mind to understand certain things. So here, by the process of electrification, that means by the process of rubbing, or else we will be calling it as the friction, the bodies are getting charged. Here, the bodies are getting charged mean that the positive charge is on the glass rod, negative charge is on the silk cloth, and in this case, the negative charge is within the body itself. Nowhere it is moving. It is not moving anywhere else. These charges are residing on the body, staying on the body. They are not moving. They are at rest. So here we observe the charges are at rest. So now we talk about the charges at rest, and this concept will be called as static electricity. So the static means rest. So this will be called as static electricity. When the charges are at rest, usually we don't find any use with them. It means we want to make this electric bulb glow, or the electric fan run, or any other electric appliances would work. There it is necessary for us to make the charges move or flow. So unless the charges are made to move or made to flow, then only we can experience the effects produced by these charges. So now Our intention is that we want to make the charges to move. It means we want the charges to flow. This flow is nothing but the current. And the charges in charges and the current of the charges. So we will be calling these charges which are flowing as current electricity. As the current electricity. So now we understood there are two types of electric current. One is the static electricity, another one is the current electricity. The charges which are at rest, this refers to static electricity. Charges which are in flow or current we will be calling as the current electricity. Now the question arises here, how can we make the charges to flow? Here, by this process up to here, due to the electrification, we made the charges to rest on a body, staying on a body. And now our intention is that we want to make the charges to flow or to move. How can we make the charges to flow or to move? That's the question here. So to understand that, we'll go with a practical or well-known example to you. You know the flow of the water. If the flow is horizontal, the water cannot flow from one place to other place. And if you want to see or to make the water flow, certainly the charges, the water to flow, there should be difference in the level. So we know that the water always flows from higher level to lower level. So for that we'll go with a small example here. Just take two containers. The sizes we are not bothered about whatever the sizes are, and these are connected by means of a pipe. And if you fill the water in the two tanks, now we understood that both the levels are same, heights are same. We are not bothered about the quantity. The quantity may be more, the quantity may be less. But even then, the water will not flow from this tank A to tank B or from B tank to tank A. So water will not flow. To make the water flow, what we have to do here, either the level in A should be more or the level in B should be more. So let us consider here the level in A is more. If the level in A is more, now we can observe that water will be flowing from A to B. So from this example we understood that the water flow will be there from high level to low level. Water always flows from high level to low level. The same concept we can be used to understand this flow of the charges. The charges also flow from high to low. But here, instead of level, we use a term called as potential. So now, by using the term potential, I just tell you a sentence here. The charges flow from high potential to low potential. The charges always will flow from high potential to low potential. High potential to low potential. Here, instead of level, I am using the term potential. And later, when we are talking especially about this potential, they will clearly understand the meaning of the potential and the definition of it. Okay. Now, one thing we understood, it's clear. To make the water to flow or the charges to flow, there should be difference in the levels or there should be difference in the potentials. So now here, up to some time when the water has flown from A to B, up to what time the water will flow until both the levels are same, until the levels are same. Then again, there will be flow will not be there. To make this water to flow continuously, what we will do, just we will use a source, a water source. There is nothing but a tap, the water source, so that the continuously the level will be increased, and so therefore the water flow will be there to B. So now, so from this water concept, we understood one thing: water flows from high level to low level, and to make the water to flow, there should be difference in the levels, and to maintain that level, the difference in the level, a source is necessary. The same we will just impart it to the charges to flow. To make the charges to flow, the charges will be flowing from higher potential to lower potential. Higher potential to lower potential. And here we require always there should be some difference in the potentials. Unless there is difference in the potentials, the charges will not flow. And one more thing here. To make the water to flow from this tank to this tank, here we use a pipe. And for making the charges to flow from one charged body to other charged body, here we also require one thing. That means here, from one body to another body, we need a conductor. So here a pipe, a conductor. So what should be there? Here one should be at higher potential, other should be at lower potential. And here always this level should be maintained. Potential difference should be maintained. To maintain the potential difference, for maintaining the level difference there, we use the source here. And for maintaining the potential difference, here also we require a source. A source is required to maintain this potential difference. So here the source is, okay, here we are doing different sources like cell, battery, generator. This here, suppose if you are having a conductor, this end is A and this end is B. Now I want the charges to flow from A to B. If you want to make the charges to flow from A to B, A should be at higher potential and B should be at lower potential. Then only charge will flow from higher potential to lower potential. Now to maintain this potential difference, what I need a source. I told you the sources are like cell, the battery and the generator. So now if I connect it with the cell, so here the charges, this will be always at higher potential and this will be always at lower potential. And here, just keep in mind that we will talk about that. This is the positive terminal and this is negative terminal. And when this positive terminal is connected to end A, this is always maintained at higher potential, and when this negative terminal is connected to the point B, this is always maintained at lower potential. So here, to make the charges to flow, it is very important, because to run the appliances, or else we can go like this, to just experience the effects of the electric current. Effects means like light effect, heat effect, magnetic effect. What are the effects of electric current? Light effect, heat effect, magnetic effect. So to experience these effects, certainly we need a continuous flow of charges. And we understood that to make the appliances to run, to produce these effects, we need the charges to flow. How the charges will flow? The charges will flow from higher potential to lower potential. How this, until when these charges will flow, until there is a potential difference. How this potential difference can be maintained? By using a source. What are the sources we have? Cell, battery and generator. Okay. Now take a screenshot and then you can go. Okay. Now we understood here the conductor A, B. To make the charges to flow from A to B, one should be at higher potential, another should be at lower potential. And if this is connected to a source, then the charges will flow from. So here a continuous flow is there for the electric current, for the charges. So now we will be calling this as electric circuit. So in this electric circuit, if you keep any appliances, it will run. If the bulb is kept, it will glow. If the fan is kept, it will just move. And if any appliances, it will produce its own effect. But for showing the electric circuit, this is not sufficient, and it may not be used also. It is not a correct way to express in a diagrammatic manner. So here, if you are going to connect any bulb, a bulb will just making the diagram like this, and now if the charges is flowing, the bulb will glow. But if If the bulb means we can make the diagram like this. But for the other appliance, if it is a fan or refrigerator or any washing machine or something else, then you cannot make the diagram. So for that, just use the symbols for representing whatever the things are here, for the source or for the connectors or for the appliances. So here, what are the symbols we use? Here is, this is what we use for a load or a bulb. And this is the symbol, already you might have learned in early classes, this is symbol for the cell. And this is the long one is the plus, and the short one is the minus. And for the battery means the group of cells. So negative connected to positive, negative connected to positive here. The grouping of cells is done. So this we will be calling as the battery. And one more thing we used is wire or a conductor. A line is used. LINA, connectors. We will be calling it as a connector. And here, continuously we don't require the flow of charges. Whenever we want to make the appliance to run, then only we require. If we don't want appliance to run, here we need some another requirement here is there, which makes the circuit or which breaks the circuit. So for making or breaking the circuit is done by a key. For this key, we use two types of keys. One is the tap key. That means this is similar to the switches. When you put on and off the tapping by tapping. This is the symbol for the tap key. And other one is the plug key. Plug key means here, this will be similar to the keys what we use for your bikes or cars. Whenever just insert a key there, then your power source will be on. So this is the tap key. And this is for the plug key. So now we have the symbols like the bulb, cell, battery, connector and the key. By using this, we can form a simple electric circuit. First, take the bulb or the load, and this is the connector. And now here is I am using a cell and a key. This makes you a simple electric circuit. And already in the earlier discussion, when I have connected a cell there, I told that the positive terminal provides you the higher potential, the negative terminal provides you the lower potential. And in our discussions, we understood that charge will flow from higher potential to lower potential. From there, you might have understood, or you have to understand that positive is high potential and the negative is at low potential. So the charge is flowing from the positive end to negative end. It is considered like that. It is considered like that. So this is coming from the starting of the electric current coming into existence. So as a tradition. So this is nothing but a traditional current. The current coming from the positive to negative is considered as the traditional. So this traditional word is replaced with the conventional. So that the current is called as the conventional current. So now we understood that charges will flow from positive terminal to the negative terminal. So if the key is closed, the charge will flow from positive terminal to the negative terminal. And the positive is considered as the higher potential, the negative terminal is considered as it is at lower potential. The current flowing from the positive to negative, this current is called as conventional current. And the meaning of this conventional is traditional. That means from the beginning it is assumed in such a manner that the charges will be flowing from the positive to negative. But to understand clearly, already you might have understood from your earlier discussions or when you are learning the basics, the positive charges cannot be moved. Positive charges cannot be removed from the nucleus. Only the charged particles that is available for you or to play with is called as they are nothing but electrons. So only the negative charges will be moving. To say frankly here, the negative charges will move from the negative end to the positive end. That is the actual thing taking place. But from the beginning it is coming in this manner. So that's why up to now and tomorrow and for the next generation also, they will learn it as the conversion current only. But here, remember, the current flowing from the negative to positive, that is the exact current, and that is due to the electrons, and that current is called as electronic current. So from this discussion we understood one thing here. What is conventional current? What is electronic current? The current flowing from the positive to negative is conventional current. The current flowing from negative to positive is the electronic current. Okay. Now, and we understood what is a simple electric circuit. Simple electric circuit means very simple. In this we require only a bulb, a battery, not a battery, cell, a key and connectors. Bulb, cell, key, connectors. With this we form a simple circuit, and this is simple electric circuit. Okay. Now, after this, so now we understood the charges will be flowing from higher potential to lower potential, and for this we require a conductor and to maintain the potential difference. So one more very important thing to be remembered forever, to make the charges to flow from one end to the other end, certainly there should be the potential difference. The potential difference is always maintained by a source like cell, battery or generator. Potential difference is maintained by cell, battery or the generator. Okay. So now, after understanding all these things, now what is electric current? How can we define electric current? So to define electric current, you have to consider a conductor. And in this conductor, just take any cross section of the conductor. Any cross section. Cross section means you just consider this as a conductor, and this will be calling as the cross section. In this cross section, any cross section, the amount of charge flowing in unit time. The amount of charge flowing in unit time. So the charge in unit time, we will be calling this as electric current. That means the charge, electric current is denoted by I, and the charge is denoted by Q, and the time in T. So now, according to our definition, electric current I is equal to Q. For what time? Unit time. That means for I is equal to Q. So here, if I, when will I will be equal to Q if the time is 1. So now, what is electric current? It is the amount of charge flowing in any cross section of the conductor in unit time. But every time we cannot go with 1 second or unit time. So let us take for some time, T time. So if this is T, then I is equal to Q by T. Okay, so this is the definition of electric current, and this is the expression for electric current. And now here, charge is denoted, the unit for the charge is, the SI unit of charge is Coulomb, denoted by C. The time is second. So I is equal to Q by T. It is Coulomb by second. This Coulomb by second will become the SI unit for the electric current. So the another unit, the special name is given for that unit. It is ampere. Ampere, denoted by K, named after a scientist. So what is the SI unit of electric current? The SI unit of electric current is ampere. What is the SI unit of charge? Coulomb. So this is the expression, and that is the definition. Okay, take a screenshot. Now we understood that we learned the definition of electric current, and we just made the expression I is equal to Q by T. And this is the SI unit of electric current. Electric current is a fundamental quantity. Electric current is a fundamental quantity, and its SI unit is ampere. And this charge is in Coulomb. And the time is in second. And this Coulomb per second is ampere. So now, we have to define what is an ampere. Well, here how to define 1 ampere? Definition of the ampere means we can go like this. How to define 1 ampere? How to define 1 ampere? Directly we cannot, but we can say like this. Electric current is said to be 1 ampere. So like that we can come. So electric current is said to be 1 ampere. When it will be 1 ampere, look at the expression here. When this will be equal to 1, if this is equal to 1 and if this is equal to 1, certainly this becomes 1. This is equal to 1 means the charge should be of 1 coulomb, the time should be of 1 second. Then the current flowing in that conductor will be 1 ampere. So now, combining all these words, we can frame a sentence like this. The electric current is said to be 1 ampere. The electric current is said to be 1 ampere if the charge of 1 coulomb flows in any cross section of the conductor for 1 second. Okay, just you can connect all the words, whatever we use here. When this is equal to 1, if this is equal to 1 and if this is equal to 1. The electric current is said to be 1 ampere if the charge in the conductor is, the charge flowing in any cross section of the conductor is 1 coulomb for 1 second. So like that you can define an ampere. Now, we need to define how much is a coulomb. How much is a coulomb? For just understanding this, how much it is a coulomb, so initially we have to go with one more related with this, that is quantization of charge. Quantization of charge. What is this quantization of charge? So when we again connecting with the earlier, whatever we have learned there, when we are charging the bodies by the process of electrification, when you are rubbing a glass rod with silk cloth, or when you are rubbing ammonite rod with the cat skin, there it is getting the positive charge and this is getting negative charge and this is getting negative charge and this is getting positive charge. And you know very well how this got the positive charge and how this got the negative charge. So from the glass rod, the electrons move to the silk cloth. Because the electrons moved away from the glass rod, here the deficiency of electrons took place, or you can say there are more number of positive charges than negative charges. So that's why this became positive, and because of gaining of the electrons or because of the excess of electrons than the positive charges, this became negative. Similarly, we can say same for this also. Why this became negatively charged body, why this became positively charged body. So here, this cat skin is having the tendency or property of losing electrons. So these electrons from the cat skin move to this ammonite rod, and because of losing electrons it became positive charge, and because of gaining electrons this became negative charge. Right. Now, whatever it is, whether it is gaining or losing or gaining, it is only due to the electrons. The electrons moving from one body to the other body. When you observe here, when the electrons are moving from one body to another body, this transfer will be like 1 electron, 2 electron, 4 electron, 1000 electrons, million electrons. So that generally should be a number. Particularly it should be a number. But a fraction of electron cannot move from one body to another body. That means half the electron or 3/4 of the electron or 0.27 electron. That means certainly it should be as a number. So that's why here whenever this is taking place, so it will be always a multiple of an electron. So we just say a statement like this. So here that charge developed on a body will be due to the electrons. Suppose if 2 electrons are transferred from here to here, 2 electrons. So what is the charge on this body means 2 into E. Suppose if the 3 electrons are transferred from this body to this body, that means the charge occupied on this body is 3 into E. 2 into E, it is the charge occupied on this body, so it is minus 2E. It has lost 2 electrons. What is the charge on this body? It is plus 2E. Here it has gained 3 electrons, so it is minus 3E. this has gained 3 electrons, so it is minus 3. It has lost 3 electrons, it is plus 3. So here we will observe here, either it can be plus or minus, and a number multiplied with E. So this is Q is plus or minus NE. So this is very important to find out the charge acquired by a body. This we will be calling as the quantization of charge. This, how can we say this in the form of a statement? The charge is always quantized. That's enough. To just say statement, charge is always quantized. To just go into the elaboration there, what is the meaning of the charge is quantized? The charge is always in the integral multiples of E. The integral multiples of E. This is an integer, either plus or minus a number is an integer. So charge is always an integral multiple of E. That we will be calling as the quantization of the charges. So after understanding this, now we can calculate the charge acquired on a body. So if I ask you, what is the charge in 1 coulomb? In 1 coulomb. Because here it is necessary for us, because we have to define what is a coulomb. To define a coulomb, we have to say in terms of how many charged particles are forming a coulomb. How many charged particles are forming a coulomb means we have to tell in terms of electrons only. So now, for this reason, we understood this quantization of charges and again coming back. So now it is 1 coulomb, and what is the, how many charged particles are making 1 coulomb? How many charged particles are making 1 coulomb means Q is equal to ME. So what is Q? 1 coulomb. M we don't know. We have to find this number. What is E? E is the charge on an electron. What is the charge on an electron? Minus 1.6 into 10 to the power of minus 19 coulomb. So E is, you can take it as 1.6 into 10 to the power of minus 19 coulomb. So what is N? It is 1 by 1.6 into 10 to the power of minus 19 coulomb. So it is, the answer will be 6 into 10 to the power of 80 electrons. Number, it's only we are going to get number. What is this number? This is nothing but number of electrons. So from this calculation we understood that 1 coulomb contains 6 into 10 to the power of 18 electrons. So now we can define a coulomb. What is a coulomb? The charge, it's a charge. How much charge it is having? It is because of these many electrons. So 6 into the 6 to 10 to the power of 18 electrons is making a charge of 1 coulomb. So we have to express the coulomb in terms of this. So this is the definition of an ampere, and this is the definition of a coulomb, and like this we can understand this. And after this, in page number 200, page number 200 in the textbook, there are some questions are there and a problem is there. Go with the problem, and we can easily already the one problem I have solved there, and the remaining thing we have to solve it. Okay, and today just we came with some of the basics, and as well as the definition of electric current, the definition of ampere, the definition of a coulomb, and quantization of charges, and expression for it Q is equal to NE. Overall, we have today we learned two expressions. One is I is equal to Q by T, or Q is equal to IT. Another one is Q is equal to NT. These are the two for life. Okay. See you in the next class. Until then, bye. Just take a screenshot.